Hi there, my name is Zane, and I just wanted to take a second to show you guys something that I've been working on in Unreal 5, which I think is kind of cool. So this is not so much a game, a full game per se, but it's more of just a tool or architectural mechanism that I think is pretty neat. It's a way to script behavior using data only and doesn't require you to hard code anything in blueprints or completely hard code anything in native C++, which means that potentially behavior could be changed without recompiling the entire game. It could be defined in data in an external source and then just read in at runtime and then executed. So to demonstrate this, I just have a scene set up right here. You'll notice there's 3 actors. They have cubes on them just so you can see their shape and so they can be seen. Notice how they are all right now square to each other. They're all facing the same direction. If I play the scene, you'll notice there they are. The center one is now rotated a little bit. If I click on this one right here, his rotation just changes randomly. If I click on the center one, it changes the rotation of the other two. And if I click on this one, if you look down in the log at the bottom, it's printing out messages. It's printing out a hello message, and then it says the number is 1. And I'll get into what that means here in just a second. So the neat part about all of that functionality is that there's no single blueprint or single section of native source that is defining that. It's defined in data. So let me show you what that means. I'll stop it and then I'll just take a look at one of these actors. These are all subclass from a special kind of actor that I've made, which I'll get into in a minute. But it's called a runtime actor. And what you'll notice here is if I click on this guy right here and look down at his properties, he has a little section under the runtime actor section. And he's got what are called action scripts. That's what I've called each one of these. These are called runtime action scripts. And under that is a number of events that can happen that can trigger arbitrarily any one of these events. They're not all hooked up right now. Only begin, play, and click are hooked up at the moment. These other ones are just for example and debug purposes. But presumably, any one of these events could trigger some kind of behavior. And so if you look on the center one, remember how the center one, when I hit play on the level, its rotation changed? Well, that is because under his begin place event, he has an action script that consists of smaller actions. And so I'll explain more detail what these are, but if you just look at it, it consists of 2 smaller steps. There's this one. They're named with gameplay tags. So this one is called target self, and this one is called random rotation. And so, as you can imagine, what happened is, when begin play happened, it started executing these little actions. The first one was to target itself, and the second one was to give a random rotation to whatever that came out with. So, in even greater detail, what this kind of allows is every single one of these smaller steps can act arbitrarily on a set of data that was provided by a previous step. So every one of these scripts, it kind of has its own little context that is not viewable by other scripts. It's only local to itself. And it has what is called a data cache. And this data cache is a place where each of these little steps can read or write variables into, and you can give them arbitrary names. So what happens in this instance is when this guy begins, it runs this target self action. And I'll show you what this does in native in just a second. But basically all that does is just return out an actor reference to itself. And you have to give it a name for it to save that under. So I've given it an output name here. It's called self. So when this little step runs, it finds a reference to itself and then writes that into the cache for this script under the name self. Then the next step, this random rotation, that little step is expecting an input of a set of actor references. It could be a single one or it's a whole array of them. But you give it the name that you want it to search for. So under its input name, I gave it the self name. This name can be arbitrary. I could change this to actor, and as long as I made these two the same, it would still run the same way. And then so this step finds this data that was saved in the cache and then does its work on it. In this case, applies a random rotation. So the effect in this case is when we hit begin play, this single actor here, he runs this set of steps in which he targets himself and then applies random rotation to whatever that came up with, which ends up being himself, which ends up giving him a random rotation. Then, you remember when I clicked on the center one, it was giving these other two random rotations. That is because under his click event, there's another action script that does almost the same thing, except there's another action here that's called target others. And all that one does is get every other actor in the scene besides yourself. But it does essentially the same thing. We have to give it a name to save its information under. So this step, it finds all the actors besides itself, and then saves them into the cache under some name. I called it others. And then there's that random rotation again. The random rotation step doesn't care where the list of actors came from or what they are. All it does is apply random rotation to all of them. So it finds that list of actors called others and applies random rotation to them. And that happens when click happens, and that results in whenever you click on this actor, these other two guys get random rotation applied to them every time you do that. This guy is basically the same. Remember, when you click on him, he just applies random rotation to himself. It's the same thing. Under his click action, he targets himself and then applies the random rotation. And then this guy, remember, he's the one who printed out log messages. These are more for debug. But again, same kind of deal. He uses some different action steps under his click event. He's got one called print hi. It takes no inputs or outputs. It doesn't save any data, and it doesn't take in any data. It just writes a console message, which is where we get this hello message. And then he also does another interesting thing. It shows how the individual steps can take in arbitrary data from any source. There's that target self again, so it's going to save a list of actors that consists of the right data. In this case, it would just be a reference to himself. That's not a great name. It's called others, but I'd probably want to call that self. But then there's another little step here that I made for debug purposes. It's called count targets in set, and that expects an input of a target set. And so you see, I've given it the name of others, which will find the set that the previous step made. And then you have to provide it an output where to save the result. So it's going to count the number of targets inside a set and then save that integer. You have to give it an integer name to save it under, and I called it count. So that will effectively save into the cache a new integer variable that is named count. And then there's another one here that's also for debug. It's called print int from cache, which does exactly what it sounds like. It takes in a name of some variable that's in the cache, and it prints it as an integer. And in this case, I gave it count. So all of these steps are arbitrary in the naming of their data inputs and outputs, and so you can string together lots of actions in this way that do very small operations on little bits of data and get very interesting results. And so this resulted in, see, this is what was printing out number is 1, because it's printing out the number of targets in the self target set. So he targets himself, it makes a set that has one element in it, it counts the number of targets in that, and then saves that into the cache, and then we print out that number from the cache, and we get number 1. You can see if I change this action step to be others instead of self, and then I hit play. If I click on this guy, if you look, now it says 2, because instead of targeting itself, it is targeting all other actors in the scene, which in this case is 2. And so the script is running exactly the same, but it's getting different data. It's getting arbitrary data, which is pretty neat. So that's kind of the functionality of this. And so how could this be useful in making it to where you don't have to rebuild the entire project if you want to change this? Well, normally, if you want to script up actions with blueprints or make changes in native source, you have to recompile a game and rebuild and redistribute and all that fun stuff. Well, because these settings are all done in data, they could presumably live just about anywhere. For right now, each actor is tracking its own set of scripts, but in this setup, if you want two actors to do the same thing, you have to set the data the same in two places or multiple places, which is kind of a bummer. Conceivably, you could instead put all of this information, like all of these steps and everything, these could go into, say, a data table. And instead of having all this data defined directly under each event, you could just give it the name of a data table row that it could go look for and get the script data there. Then, in that case, you could just give two actors the same data table row, and they could therefore share functionality that way. Even better, though, would be to save that data of each script perhaps in like an external JSON or CSV file. Because data tables, if you just use them as is as a regular U asset, you still have to open the editor and make changes in there and then save the blueprint, and you would still have to recompile and do all that. Whereas instead, if you saved all the action steps for each action in like an external file and then read them in at playtime, you could literally just make changes to a file and then rerun the game, and it would read differently, and you would have different behavior that way, which I think is pretty neat. So how does this kind of work under the hood? Overall, this is actually built upon the gameplay ability system, which I think is quite suited for this. It might be a little bit cumbersome, actually, because gameplay abilities require like granting before being able to be used, and that's kind of cumbersome in this context. But essentially, every single one of these small actions that I've defined is a gameplay ability. It's a very small one. Like such, though. So I'll show you. Remember that... where's that one? Like, remember that print hello step that just prints the log message? This right here is all it is. You get to give it its gameplay tag name. That's how it's... Each one has to have a unique name. That's how it knows what ability it is. And then it has a little run function that you can override to do whatever you want it to. In this case, this one just prints hello. Where's that random rotation one? This is an interesting one. So remember that set random rotation. There, right here is where it gives it its name. There's actually a little bit of protection happening under the hood, or a little bit of validation to make sure that this step, or this action step, will have the data it needs. So you can tell it ahead of time, you're going to need at least one target set data type as an input. So in this case, like right here, when I give it a name under the random rotation, it will search for this name in the cache under the target sets to make sure that it exists first. And if it doesn't, it'll actually complain and error out. So there's a little bit of protection. And then in its run function, you'll kind of see what it does here. There's this custom data type that I made. It's an action target set. It's basically a T-array of actor references, but it makes a local version of that, and then there is mechanism to search the cache for different data types for different names. So it inputs the name that it received. That would be this guy right here, input name 0. You could add others if you wanted to, like, I don't need to, though, because it only takes one input. But yeah, so it will search the cache for a target set with the name that I've specified, and then fill out this local one. And then now, right here, it just loops through that target set and applies random rotation to it. And then it's done. And so that target set can have one target. In the case where it does the target self, that always comes out with 1. Or the target, all others, could have n number of targets. And conceivably, you can make much more complicated types of target acquisition. So I'll show you in a minute a little more kind of a use case of this. But like, say you've got like teams, for example, you could find all the other actors that are on your team to do something to them, or all the other actors on the opponent's team to do something to them, and get really creative with the way that you pick out sets of actors to start doing things to. what am I trying to do here? So to give a little better idea, I have another level here in this project that is a little more full-featured. Let me skip to it. And it's kind of originally why I wanted to kind of work on this whole mechanism. Right, so here we are. So this is a card game, a CCG, as it were, like a collectible card game. Think Magic the Gathering or Yu-Gi-Oh! So I can, the placement logic isn't going so well, but I can place cards down, and you see it is multiplayer. Multiplayer is working. But in any case, so that's all I need to do here to show you. Let me pause it. So presumably this is where a mechanism like this would be really cool. So if you think back to like Magic the Gathering or Yu-Gi-Oh, it's full of unique cards that each do their own kind of thing. So some cards, they deal damage, some cards, they can heal, some cards, they do all sorts of fun stuff. Well, presumably, this action scripting method would be great for defining behavior for each unique card. Because in a game like this, there are a lot of discrete events that happen that would be useful, or that could be used for triggering different events. For example, like when I played down a card, that would be a play card event, kind of analogous to the click or begin play events. When a card gets played, it could do something fascinating, like it could target a random opponent card and deal some damage to it if you wanted to, just on playing it. And then in this game, there's also a phase where you get to do attacks back and forth, and then so every card would have a basic attack function. You could decide what to do in that case too. Maybe a card just has a basic attack that deals some damage to one target you select. Maybe one card deals like shockwave damage. When you target a card, it also deals damage to the opponent cards adjacent to it. And that's where I was talking about the creative targeting functionality. Rather than just targeting itself or all other cards, you could get really creative with how targets are selected and what to do to them. Like I mentioned, this whole game here, this demo, is fully backed by the gameplay ability system, meaning that these cards actually have attributes and use gameplay effects. So it would not be hard at all to make each individual action step apply gameplay effects. So you can make an action step that heals. So you can make a card when it attacks. It can, in one script, it can deal damage to one target and heal itself by targeting itself. The possibilities are quite limitless here. Oh, as another thing too, as I forgot to mention, but you can also preload the cache with data ahead of time. So like if I go back to this other level, end the session. If I go into one of these guys' scripts, you can actually give the cache constants ahead of time, so you don't have to derive them from anywhere. So like I could add an integer constant right inside called number. Actually, instead, I'll do it in, where's the one that prints the number? Yeah, so this is the one here. This guy has that print integer from cache. It was printing the number of targets that it found, but instead I can just preload it with a number of some kind, 42. So now when this script runs, there will already be an integer named number, and instead of using the count that it's deriving, I can just give it number. And now when I click on him, see, he's running 42 instead, because his script now says we'll use that other constant instead of the one that is derived. Yeah, so that's about it. This is, like I said, this isn't so much a full gameplay. This is more of a gameplay architecture mechanism. The whole premise would be to where your designers wouldn't have to rebuild the game on their own. They wouldn't have to worry about doing that. So engineers would be the ones to make all of these small, discrete little action steps that do something, and it could be up to the designers to stitch them together using the cache variables to make very, very complex behaviors. There is also another gameplay ability that is running each smaller step. So like I said, so basically each one of these events here is actually kicking off a gameplay ability itself, and then that gameplay ability, it's called the host process, that's where the cache lives, and then that gameplay ability is what executes every subsequent smaller step inside it. And so they're completely autonomous and like isolated from each other. They do reset automatically after every time, so that's why you're able to run them over and over again. But yeah, so I thought this was very interesting, and hopefully you did too. Thank you very much for watching.